Hello all, welcome back to this channel where I solve Leetcode's problem of the day with you all. So, before proceeding to the video, let me tell you about myself. I'm a guardian at Leetcode and have solved more than 1000 DSA problems across various platforms. So, I have been through this grind and I consider that you are learning from someone who has been through this phase. Okay, so I could definitely help you with the best explanations and strategies, right? So let's proceed solving the question without wasting any time. So it's lead code problem number 2016 and it's an easy level question. And the question says that you have to find out the maximum difference between increasing elements, right? So let's look at the question first. Okay, so question says that given a zero indexed integer array nums of size n, find the maximum difference between nums of I and nums of j, that is, nums of j minus nums of I, such that it simply saying that you have to find out the difference between um two elements of the array such that the index of the first element, right, is greater than the index of second element. That is, j should be always greater than I, right? And if no such cases exist, then you just have to return -1 to it, right? Okay, so let's look at this example and try to understand what this question is saying, right? So, so if you consider that your array is 7, 1 minute, yeah, 7, 1, 5, 4, okay? So this is your array given, and it has said that you have to let's first do the indexing also. 0, 1, 2, 3. This is the indexing of this array. So it has said that in this increasing form, you have to find out the maximum difference between two elements of this array such that the index is the index of the first element of the subtraction is always greater. Like you can not find the array of 0 minus array of 1. You cannot find out this, right? Why? Because here 0 is less than 1. The index position of this first element is less than the index position of the second element. So we can definitely not do this, right? So what can be done, that the valid cases would be this: array of 1 minus array of 0. That's the one which shall give you 1 minus 7, that's -6. And remember, you don't have to take the absolute value, right? It will just be the value which is given. Okay, so this is the one. So let's try seeing that if our pointer was at 7, right? What would be the case? Okay, so how many cases could be formed from this? So let's see that first. Okay, so we can find out the index of 1 minus 0, that is 1 minus 7, that's -6. We can find out. Okay, next up, we can find out 5 minus 7, right? 5 minus 7, that's -2. Okay, and then we can find out 4 minus 7. 4 minus 7, that's -3, right? And next up, what we can find is 5 minus 1, right? This index 2 minus index of 1, right? So we can find 5 minus 1, and that's 4. Let's see next. Yeah. And then you can find out 4 minus 1, that's index of 3 minus index of 1, right? So it shall be 4 minus 1, right? 4 minus 1. So it will be 4 minus 1, and that's 3, right? And then we can find out 3 minus 2, which shall be 4 minus 5, and that's minus 1. I hope that we have covered up all the cases, like here, here, this, and then this, and this, right? So here 3, here 2, and here 1. So altogether, 6 cases have been made. So out of all this, right, out of all this, which is the maximum possible difference which you could spot? So it is this one, right? 4. So it's simply that we have to return this value only. The maximum possible difference in the increasing element, right? So this is what we have to do. It's a very simple question, right? And it could be done with two approaches also. One could be, I could think of is using a for loop, right? And I consider the maximum difference initially as minus 1 only, right? So that if I don't find any difference greater, I don't find any positive difference between the increasing element, right, all over, then I could simply return minus 1 only. Next up, I can take a variable whose value is already initialized to my first index of this array, right? And then I could just simply compare it, right? I will do the comparison that if the next value is actually greater than, then store the difference. Otherwise, if it is less, then make this element equal to that variable, right? So this is the procedure we can do in one way using the for loop. Another approach I could think of is, like, one approach is what I have thought of is using the for loop, right? As I said, this is going to be the first approach. Second approach is like using two pointers. What I can think of is that we shall take two variables, right? L and R, and we will just simply put up a while loop condition that R should always be less than N, right? Obviously, we just want it till there only. And next up, we'll simply compare that if the element at L is less than element at R, then we will store the difference. Otherwise, we will make our L equal to R, and we will increment our R. Okay, so let's look at the question. So, all right, let's see our first approach first. Our for loop is given, and I think for the case of for my first approach, I have already told you that how things would be done like this, right? So I don't think that we need to discuss this approach, but okay, still. So as I said that I'll simply take a variable that's max difference, right? And I will initialize it with minus 1 already. Okay, so that if I don't get any positive difference in the if I don't get any difference greater than this in the whole array, I can simply return minus 1 only, which is given that default case, right, in the question only. And next up, that's given to us, I want to store my first indexed value, right? So I will just simply take like int of first, which will just store my uh, 0th element, right? And I'll just now simply take the for loop, right, where it shall be traversing from 1 till n, and we shall increment it, right? And now I'll just simply put up a condition that if my this indexed element, that's ar of I, is greater than my first, right? So what will happen that simply take account this difference, right? So max d will take math dot max of max d and the difference between the two, that is ar of I minus first. This is a simple thing, right? And in the else case, that if it is less, what will happen? That only your that first will become that nums. Oh, sorry, I took AR, right? ARR of I. It will just get updated. This is a simple thing, and by the end, you will just return your maximum difference which you have accounted. Let's try to dry run this, right? So just say that I have an example. Okay, consider that I have an example of 4, 3, 6, 2. Okay, so according to this approach, what will actually happen, right? Your first here would become equal to 4, right? Your max d is already equal to -1. And now our loop, and we shall iterate from this position till here, right? Let me do the indexing also, right? This is the indexing. So we shall traverse from this element till this, right? And it has said that if AR of I, that is AR of 1, is greater than first. So is this greater than first? Is 3 greater than first? No. So what will happen? It will see the next else case. That is first will become equal to AR of I, right? So now our first will become equal to 3. That's the least possible value, right? So, okay, next up, what will happen that your AR will become 3, will become 2. Okay, so it becomes 2, and what will happen that it will come see that if AR of I is greater than first, that is 6 greater than 3. Yes, so earlier that your max d was -1, it will get changed to the difference between this AR of I, that's 6, and first, that is 6 minus 3, which is equal to 3. Okay, so that's the max D has been stored. Next up, your I would become 3. Okay, so AR of I is greater than first. So 2 is not greater than 3, so it will look for the else case, right? So first will now become 2, right? So first will now become 2. Okay, and then it will come out of the loop, and our maximum difference has already been has already been calculated, and that's how you will get 3 as your answer, right? And that's how you can see the possible cases. If I try to make possible cases for this question, so it will be like 3 minus 4, right? Which will be -1. And it shall be 6 minus 4, which will be 2. Then it will be 2 minus 4, it will be -2, right? Next up, it shall be 6 minus 3, which will be 3, and then it will be 2 minus 3, which will be -1, and 2 minus 6, which will be -4, and I can simply clearly see that 3 is the maximum possible difference I can spot in this array with increasing elements, right? And that's how our code is also returning. I hope this approach is clear to you all. Was a very simple approach, right? Let's discuss our second approach now. Okay. So our second approach is actually using a two pointer method, right? It's actually using two pointer method as I had mentioned earlier, right? So what has to be done in this, as I said, that we'll take variables definitely, which would work as pointer. That's what this approach says, two pointer, right? And it shall be L, which I'll take it as 0, right? And R, which will be 1. To uh, to take this first two elements, like as the starting, right? So this is what we have taken, and again, what you will require would be your maximum difference, a variable to store the maximum difference, right? Which will again be initialized with -1. Okay, so I hope this is clear. And then what can we do? That we will simply put up a condition, that a while loop condition, that your R should be less than n. It should not proceed this, where n is actually the length of the array, right? And next up, what we will do is simply put up a condition that if ARR of this R is greater than ARR of L, right? So what will happen, that we will take max D and store the maximum value, max of max D, and this difference, ARR of R minus ARR of L, right? Okay, and in the else case, what will happen? In the else case, we will say that our L should increment. Our L should become equal to the R, and R should be incremented, right? That's how we can proceed. So let's try to dry run this, and then our max t shall be returned, right? So let's try to dry run this also, and we shall consider, 1 minute. Okay, so let's consider an example of say 2, 5, 6, and 1. Okay, so if this is your example, and I'm indexing it from 0, 1, 2, 3, right? And as I've already told you, that in order, since we are using two pointer method, right? So we need to take two pointers and we need to initialize them with some of the indexing values in such a way that your L should always be less than R, right? Because that's the condition we have been given. So I have taken them as side by side, like the initial 0 and 1. Okay, so if it's 0 and 1, and maximum difference is currently -1, so it has said that R is less than n. So 1 is definitely right now less than 4. That's the length of the array, right? Next up, what will happen, that it's not going to compare if AR of R is greater than AR of L. So is 5 greater than 2? So is 1 minute. So is 5 greater than 2? Yeah, this is correct. So what will happen? Your max difference would store this difference. So max difference, which was earlier -1, would become now equal to 5 minus 2, 3, right? So this is what will happen. Next up, what will happen? R will increment, right? So simply said that R has to increment in every loop, right? So that we can proceed ahead. So R is now 2. So you have said that R is now 2 and L is at its initial position only, that's 0. And you will now compare these two. 6 is greater than 2, that's correct. So what will happen? That your max D will become 6 minus 2, right? 6 minus 2, it will become 4. And R will now increment. It will now become 3 and L is still 0. So what will happen here? That it will again check the condition of AR of R, that is AR of 3 is greater than AR of 0. So that's not correct. That's since 1 is less than 2. So the else case would be taken in consideration and your L would now become equal to R. So L will now become, so in this next case, R is already equal to 3. Now L will become equal to 3, right? And your LR will increment by 1. So R now becomes 4 and L is already 3. Okay, so in the next loop, it will check that 4 is less than 4. So this does not fulfills this, it's a false condition, so it will just come out of the loop and the maximum difference which has been stored, that's 4, is will be returned, and that's what we can clearly see, that 6 minus 4 would be the greatest or sorry, the maximum difference which we can find in this whole array. So it's an easy question, let's try to code it. Yeah, and as I have always said, that if you code in C++, just stick to this video till the end. Okay, understand the approach, and I shall provide you with the code by the end of this video also. Okay, so first we need n to store the length of the array, right? And what I said that we need to account the difference. So for that, I'll take max d, which is equal to -1, right? And also like my first. Okay, so I'll take this as equal to nums of 0. Next up, I'll take my for loop, which will iterate from 1 till n minus 1. Okay, and I'll now just check that if nums of I is greater than first, right? So your max D would store the maximum difference, comma nums of I minus first. Okay, in the else case, what will happen? Should I use brackets? I should actually use more brackets so that it would be clear to you how the process is being done. In the else case, we will simply update our first variable with the current element, right? And yeah, and just simply return your max D. Try to run this. This is accepted. Submit it. And this is accepted with 0 millisecond runtime and it beats 100%, right? Let's see our second approach also. Okay, comment this out. Comment this out as well. Okay, so I'll now take int max t is equal to -1 as I said. Sorry. And we need two pointers. So this is my two pointer method. Okay, and this was the initial one, right? Okay, so now int L is equal to 0 and R is equal to 1, right? And now just simply traverse it and give the condition that R should always be less than N. Okay, and now give the condition that if nums of R is greater than nums of L, okay, then your max B should store the maximum difference between nums of R minus nums of L. Okay, you should use more brackets, right? Especially if you are a beginner, right? In else case, your L will become equal to R, and then just in every loop you need to increment your R so that you doesn't end up with stack overflow error, right? And now just return your max D. This is also accepted. Let's submit it. And this is again accepted with 0 millisecond runtime and beats 100%, right? Okay, so this is your C++ code for the both approaches. Like this is your minimum tracking approach, yeah, and this is the two-pointer approach. Please refer to it, and it was an easy question, definitely. Uh, so yeah, we shall meet tomorrow again with a new question. Till then, keep learning and keep growing. Bye bye.